This is another standard error problem. In this problem, I'm still sampling from the same population of 4 people, but in this problem, I'm selecting a sample of 3 people instead of a sample of 2 people. In this problem, I'm randomly selecting a sample of 3 people from this population, and I'm going to record the heights of those 3 people, and then calculate the mean of my sample to estimate the mean of the entire population. So the only thing that's changed is my sample size. And now I want to know what the standard error of all of the possible samples of 3 people equals. If I randomly select a sample of 3 people from this population, there's 4 possible samples that I could get. In other words, there's 4 possible combinations of 3 people. And I'm going to end up getting one of those possible combinations as my actual sample. And each of those 4 possible samples has its own sample mean. And the standard error that I'm looking for is just the standard deviation of those 4 sample means. So we'll go through both methods to find the standard error. So we'll go through method 1 first. The first step in method 1 is finding the means of all possible samples. Now I'm dealing with, since I'm selecting a sample of 3 people, I'm dealing with all possible samples of 3 people. So now I'm going to sort the population into all possible samples of 3 people. There's going to be 4 of them. I'll explain why. So to sort this population of 4 people into all possible samples of 3 people, we just need to leave out one person each time. I'll explain what I mean. In sample 1, we'll leave out person 4. We'll just include persons 1, 2, and 3. In sample 2, we'll leave out person 3, so it'll just be 1, 2, and 4. In sample 3, we'll leave out person 2, so it'll be 1, 3, and 4. And then in sample 4, we'll leave out person 4. It'll just be 1, 2, and 3. So we just left out a different person each time. In sample 1, we left out person 4. In sample 2, we left out person 3. In sample 3, we left out person 2. And in sample 4, we left out person... Oh wait, I'm sorry, I did this wrong. We should have left out person 4 in sample 4. Yeah, so I'm sorry. This leaves out person 1. I'm sorry, this leaves out person 4. This leaves out person 3. This leaves out person 2. And this leaves out person 1. So we're just leaving out a different person each time. So I'll write down the heights of the 3 people in each sample. So this is person 1, person 2, and person 3. This is persons 1, 2, and 4. This is person 1, 3, and 4. And this is persons 2, 3, and 4. So we need to find the mean of each possible sample. To do that, we just add the 3 numbers in each sample and divide the total by 3. So let's see what we get when we add these 3 numbers and divide the total by 3. Comes out to 52. X bar is 52. Remember, X bar is just sample mean. And we just need to do the same thing for the other 3 samples. I already did the work. For each sample, I added the 3 numbers and divided the total by 3. So now I have all 4 sample means. So I added these 3 numbers and divided the total by 3. I added these 3 numbers and divided the total by 3. And I added these 3 numbers and divided the total by 3. Now that I have all 4 sample means, I'm done with step 1. And now step 2 just says to find the standard deviation of the 4 sample means that I calculated in step 1. So we'll write out the 4 sample means. So we're going to find the standard deviation of these 4 numbers. Remember that the first step of finding the standard deviation is just finding the mean of the values. So we just need to find the mean of these 4 numbers. To do that, we would just add the 4 numbers and divide the total by 4. I already know what the answer would be, so I'll just put the answer down here. So we know the mean is 53. So we just have to subtract each number by 53 to get the deviations. I just finished the work. I subtracted each of the 4 numbers by 53, and I got these deviations. So what we've done so far is we've calculated the means of all possible samples of 3, and we got these 4 sample means in step 1. Then we listed out those 4 sample means right here, and then we just calculated we calculated the mean of the 4 sample means. We added these 4 numbers and divided by 4, and it came out to 53. We subtracted each value by the mean of 53. And then these answers are the deviations. Now we have to multiply each deviation by itself to get the squared deviations. So we're just multiplying each deviation by itself. Negative 1 times negative 1, negative 0.33 times negative 0.33, 0.33 times 0.33, and 1 times 1. After we multiply each deviation by itself, the answers will be our squared deviations. So negative 1 times negative 1 is 1. Negative 0.33 times negative 0.33, well, that's really just 0.33 times 0.33. We don't have to worry about the negative signs because they cancel out anyway. So 0.33 times 0.33 is 0.1089. We'll just round it off to 0.11. 0.33 times 0.33 is 0.11. So negative 0.33 times negative 0.33 comes out to the same answer as just 0.33 times 0.33. Whenever you multiply 2 negative numbers, the negatives cancel out and you get a positive answer. 1 times 1 is 1. Now we have our squared deviations, so we just have to add the squared deviations and then divide the total by the number of squared deviations to get the mean of the squared deviations. We divide by 4 because there's 4 of them. The answer is 0.555. I'll just write out 0.55 right here. Well, I'll just leave all 3 digits, and then the square root of that is our answer. It's about 0.74. That's the standard error. So we went through method 1, we calculated the mean of each possible sample of 3 people, and then we just calculated the standard deviation of the sample means, and that's the standard error. Now, method 2 will be using the standard error formula. I left all of this work that we did in the first problem because it would just be the same work over again, because in this problem, the 4 population members haven't changed. These 4 numbers are still the same. So the population standard deviation hasn't changed. It's still just a standard deviation of these same 4 numbers. So the population standard deviation is still 2.24. The only thing that's going to change is step 2, which is actually using the formula. So in step 2, so I'm going to separate this out because this was all from the old method. This is our new work right here. So we're still going to plug in our population standard deviation of 2.24. It's still just the standard deviation of the 4 people in the population. So that's sigma, the population standard deviation. The number that's going to change this time is little n, because now we're dealing with a sample size of 3. We're finding the standard error of all possible samples of 3 people. So our sample size is 3. Our population size is still 4, because there's still 4 people in our population. So capital N is still 4. So now it's population size of 4 minus sample size of 3 over population size of 4 minus 1. Now we're just going to do this work first again. So 4 minus 3 is 1. 4 minus 1 is 3. Now we have 1 over 3 in here. Inside here, we'll divide 1 by 3. We just have to divide this fraction. 1 divided by 3 is about 0.33. So now we have Now that we're down to just having a number under the square root sign, we'll find the square root of that number. So the square root of 0.33 is about 0.57. So here's the so now we're finished with this part right here because we already found the square root. Now we just need to find the square root of this 3 down here. This is 1.73. So it's going to be 2.24 over 1.73 times this number right here. Now we just need to divide these two numbers to get rid of the fraction. So 2.24 divided by 1.73 is it's about 1.29.